On page 251, I have this equation here for finding the angular momentum about an arbitrary point A. So I'm going to use this to find the angular momentum about point O. Okay, so I have moment of inertia about g times the angular velocity plus d is the moment arm here. I'm looking for the angular momentum about point O. And so that would be the distance between g and O times the mass times the velocity of g. Then the moment of inertia about g, since they gave me the radius of gyration here, that would be the mass times the radius of gyration squared. And then from what they gave me, this relationship here, I can bring the distance between g and O over to this side, and then I have the distance between P and G times the distance between G and O. Okay, so now I have this relationship here. So that came from this equation and this equation. And then the velocity of the mass center, since O is a fixed point, is equal to the angular velocity times the distance between G and O. So I can take that and I can replace the distance between G and O times the angular velocity with V sub G. Then I have the mass here in this term and in this term, and the velocity of the mass center in both terms, so I can pull those out, and this is what I was trying to show. Okay, and point P is the center of percussion. This is a special point, so if you have a baseball bat and the baseball hits the baseball bat at the center of percussion, then there is no sting on impact.